Okay, so I wasn't here the day we started with patty paper, so let's start by talking about patty paper. First of all, if you ever make a mistake, don't erase on this stuff. It doesn't erase very well. This is a box of 1,000 sheets. I think I can afford a couple extras. And I have about 40 of these boxes. So we're not going to run out of patty paper. Does anybody know why it's called patty paper? Yeah, it's used to separate hamburgers. You'll notice that there's a shiny side and a rough side. Which side do you think you want to work on? The rough side. Why are we using patty paper? Is it because we've got these cute little 5-inch squares or whatever they are to work with? They're 5.5 by 5.5? No. The reason we're using this is because it does some cool things. By the way, this is just glorified wax paper, cut into cool little squares. The thing that we're going to use it for most is if you fold it and crease it, don't do it, just watch, and open it up, you can easily see that crease that you just made. And we're going to do all kinds of constructions with this in the future, in fact today, and that's going to be advantageous to us. Okay? We're good to go? Excellent. Somewhere on this, put your name, and put a 1 and circle it so we know that this is our first sketch. I'm going to give you some instructions, and then I'm going to ask you to explore. That's why you have the 6-in-1s on your table, because you're going to take some measurements. Now, there are 26 of us in here. Therefore, everybody's is going to be different, so your measurements won't be the same, but the findings should turn out to be the same. And that'll make sense as we start working through it. Okay, so in the center of that piece of patty paper, doesn't have to be horizontal, doesn't have to be vertical, this is where you get to express your creativity. Draw a segment AB. Using your 6-in-1, literally just draw a segment, label it AB. Probably want it to be somewhere between, I don't know, 7 and 10 centimeters long, so it's big enough you can work with it. I would put it somewhere smack in the middle of the paper, but it's entirely up to you. AB, aardvark badger. Okay, anything tough about that? Anybody have trouble with that? Outstanding. This is going to work great. Carl, you had trouble?
No, I don't have.
How long were you going to sit there before you got done?
No,
Are we missing a 6-in-1 somewhere? Can you table have an extra one?
We did it, but it's broken.
You broke one of my 6-in-1s,
I
Mom?
did not. It broke it when I acquired it.
So you went and stole an unbroken one from somebody else?
No, we had an extra one, so I took this one. I didn't break it, Kevin.
Sorry, Molly, they're only $1. You can get it to me later.
That adds up.
Yeah, it adds up a lot.
That was.
I'm going to pull the school teacher in the salary. Okay, first simple construction. Pick up your piece of patty paper. Fold A onto B and crease it.
Wait, you want it
Oh, like this?
You're driving the bus. Fold A onto B and crease it.
Doesn't matter which way.
Fold A onto B and crease it.
It doesn't matter which
Well done. If you can't see your crease clearly, A, crease it harder, or B, use your 6-in-1 to draw in that crease so you can see it easily. What kind of geometric shape did we just make with that crease?
A plane.
Nope. What kind of thing is that crease? Is it a segment? Is it a line? Is it a triangle? Is it a circle? Is it a bear? What is it? It's a line, correct. Now, technically speaking, it's a segment because it ends at the pieces of patty paper, but we're going to consider it a line. The point where that line, sorry, let me start over. The point where your segment and your crease meet, label it as M, as in mongoose, so that we're all consistent.
Why don't you use monkey? You always use monkeys.
Because I don't like monkeys.
Oh my gosh, I saw her.
Okay, so now, what you and your group need to do is find some interesting things about that construction you just did. If you have an idea, it needs to be backed up with measurements. Okay, do it, go.
Lines that are most likely same time.
Oh my God, Grace. Oh my God.
The line going down.
All right, what'd you find?
Oh,
No, we heard enough out of you. Addie, what'd you find? Good. So Addie just hypothesized that AM is equal to MB. Did you measure them?
Yeah,
How long are they?
mine were each 4 centimeters.
Good. Did anybody else measure those two segments? Did anybody else have 4 centimeters? Really? All right, good, good. For those of you that don't have 4 centimeters, did you screw up? No. But you should have those measurements on your piece of patty paper. Okay, so Addie, what does that tell us about the point M?
It's a bisector.
Good, also known as? No, not yet. Just about the point M.
It's a midpoint.
Good, beautiful. M is the midpoint of AB. Okay. And again, you all theoretically have 24 different segments. You all did the same construction and you all created a midpoint. All right, Eddie, what else did you find about this diagram? You just said it before.
Oh, it's perpendicular.
It's perpendicular. Did you measure that angle?
No.
Anybody else measure that angle? Well,
Yeah, it's perfect.
it's perpendicular. Okay. For discussion purposes, let's put a point somewhere on the crease and call it T, as in turtle. So what's the relationship then between the line TM and the original segment AB? It's perpendicular and? It's perpendicular and it bisects. Want to guess what the line TM is called?
Turtle mongoose.
Yes. In this,
Well done, Mom.
in this particular instance, the red line is called turtle mongoose. But in general, what kind of thing is that line?
A line.
It is called a perpendicular bisector. You can write down whatever you'd like. Why is it called a perpendicular bisector?
Because it bisects, it makes it perpendicular.
It's pretty straightforward. It's perpendicular and it bisects. Okay, we good? Last thing. Measure the distance from A to T, aardvark to turtle, and the distance from badger to turtle.
Should we draw a line?
I would, but you don't have to. This is America. Measure the two green segments.
5,
TJ, what'd you find?
That common size equals.
Really? So AB is equal to AT is equal to TB?
Yes.
Nice. Holly, what'd you find? Do you have all three of those the same length? Are your two green segments equal to your yellow segment? No.
Yes.
Yes? Yours is also equilateral.
On 9.
Mine is
How many have, how many people have an isosceles triangle? Wait a second, hold on, let's back up. Think about the question I'm asking you. How many of you have an isosceles triangle ATB? It's a simple question. Triangle ATB. How many of you have an isosceles triangle ATB? Why should TJ raise his hand?
Because all equilateral.
Yes.
Good.
It's like a.
For those of you that have an isosceles triangle, which should be all of you, how many of you happen to have an equilateral triangle? Okay, that's just a fluke. Happened to work out that way. What we should have found is that this is congruent to that. Does that matter where you put T? No. Now, these two guys happen to pick T in the exact spot where it gave you an equilateral triangle. That won't always happen. And you should notice that regardless of where I slide T up and down that segment, it'll always make an isosceles triangle. Okay? Any problems? Beautiful. Now, we're going to do a little bit more construction with that later, but I just wanted you to make sure that you understand the basic concept of how to get a perpendicular bisector and or what a perpendicular bisector is. So let's change the problem a little bit. You might want to get out some notes here, more so than just your patty paper.
graph paper.
You don't need graph paper. You can if you'd like. Hans, what's your favorite number between 1 and 10? 10. And what's your least favorite number between 0 and negative 10? 0. Beautiful. Bryce, what do you like between 0 and... let's go negative this time. What's your least favorite negative number?
-2.
Any particular reason? Okay. And what's your favorite negative number?
-7.
Okay. It's not completely random, but do you understand the idea that I just chose 2 points? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H. And 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay, so I chose 2 points at random. I didn't need to graph them. In fact, you're going to be doing these problems without graphing them. But the question is very simple. What's the equation? Hold on, let me start over. how would you find the equation of the perpendicular bisector of BH? Wait. Take about a minute and talk with your group to come up with an approach. If you're feeling all fancies in your pantsies, attack the problem. So in a minute and a half, your group should have a suggestion on how to attack this problem. What's the equation of the perpendicular bisector of the segment BH? Did you identify the group?
Wait, so.
What do they think?
The midpoint would be.
You guys buy into that? Okay, cool.
Find the distance between the axes. Find the distance between the axes.
You got it? Have you just said a word to each other? No, why two minus one?
So what did you do?
Say what?
6 and 3.5. 6 and 3.5.
No.
Wait, what?
No, it's changes.
By the way, here's a helpful tip for you. If you're going to spin my 6 and 1 around and break it, don't do it right when I'm standing in front of you. Got it? At least Molly did it discreetly when I wasn't over in that back corner. What they all say.
But now he's got a protractor and a ruler.
All right, Hans, let's hear your idea.
So you find the slope of BH, and then wherever it is, you take the reciprocal, so like the opposite of it, and then you could put 2 points on a line that would follow that slope.
It's not horrible. It's a good start at least. Let's review a little bit for those folks at home. Well, that's not his problem. How do you find the slope? Okay, delta y over delta x. So we get into the discussion that we've had in the past about conceptual understanding versus memorization. So some of you have no idea what a slope is. But you know that if you take y2 minus y1 over x2 minus x1, this magical number appears. And you can do all kinds of fun things with it. Some of you, however, have no idea what the formula is, but you understand that it's change in y over change in x. Somewhere in there, you got to be able to find the medium so that you can calculate a slope. Okay, so Hans, we calculate the slope of BH. Then you said take the opposite reciprocal, right?
Yeah.
Okay, and we'll go through this whole calculation in a second. How is that going to get me the equation of that perpendicular line? Or I should say, what chunk of information am I missing here?
That's 2 points.
Right. Is it possible, given just a slope, to find 2 points on that pink line? Not knowing the equation of that pink line. No. So what else can we do?
You find like the middle point of BH.
Beautiful. Find the midpoint of BH. How do we do that?
Formula x
Okay, so midpoint formula, which is?
x1 plus x2 over 2. That gives you first coordinate x, and then y1 plus y. Okay.
Average of the x's, average of the y's. What are the two things you need for the equation of a line? And? Slope, point and slope. Do we have a point? Yeah, the midpoint. Do we have a slope?
Yeah.
Yeah, using the process that Hans just described. And that should give us the equation of that line, of that pink line. So let's do the calculation.
The slope of BH is equal to -7 minus 0 over -2 minus 10, which is -7 over -12, which is 7/12.
So if the slope of BH, here's what I don't understand. Do you have any idea what you're doing right now? You do. So finish that problem. We'll wait. Oops. Yeah. Hans, back to you. If the slope of that green segment is 7/12, what's the slope of the pink segment?
12 over, negative 12 over.
Good, -12 over 7.
Midpoint, let's call it M. So M would be located at 4 comma -7/2.
Do I know where the point is? Yes. Do I know what the slope is? Yes. Can I put that together in the equation of a line?
The answer better be yes. Okay, so MK.
Now, aside from being able to do the work, if this were an actual problem,
We wouldn't need this, nor would we need this, because I'm assuming that you know how to find a midpoint and a slope.
the other thing to take note of is how things are carefully labeled. I found the midpoint M, I labeled it as M, I have the coordinates labeled. I found the slope of BH, took the opposite reciprocal to find the slope of the perpendicular, and put that together to get the equation of the line MK. You could probably get by without all that careful labeling now, but in the calculations we're going to do in the future, you're going to need to keep track of all this stuff, so you want to be very careful. You don't want numbers just popping up out of nowhere and not understanding what they are. Points should be in parentheses, slope should be fractions, unless of course it's a whole number. Right? Find the equation of the perpendicular bisector of segment AB. Once you get an answer, check with your group to see if they have the same answer as you. If not, figure out who made the mistake.
Can we have decimals?
No fractions.
answer.
Show us the work to get that too. Question?
Yeah, should be some too.
Okay, hold on, let her finish, then we'll make corrections. Everything else look good?
Is anytime.
Thank you.
Okay.
All right, we have that. All right, what'd you say, Holly?
Okay, so I agree with this. Samantha, you see why there should be 2?
Taking the average, divide by 2, not by 3.
Yeah.
Okay, so this should be a 2. And then what was your other problem, Holly? Okay, so remember I was talking about labeling things clearly. My question would be, Samantha, what's that the slope of?
That's the slope of the original line.
Okay, so this would be the slope, and the way I would denote that is to do the slope of AB is that. So therefore, we want the slope of the perpendicular, which would be 7 over 25. Okay? What's the matter?
Yeah, it does.
It just,
Is this one line, is that a minus sign?
Yeah.
It should be wrong.
it should be positive.
16 minus negative 9 is 25 over, yeah, it should be positive. Positive, so then this would be negative. Okay, bingo.